Hello everyone, and a warm welcome to the latest edition of the Mobile IT Community of Interest, the November meeting. Thank you very much for joining us today. Before we get started, I'd like to review how to use this GoToWebinar system in order to optimize your experience. You can interact during the session using the GoToWebinar system on the right-hand side. You are all on default mute settings due to lots of participants on the call. However, you can get the audio over the telephone or the speakers of your computer to improve sound quality if needed. The panel is set to hide automatically. Please use the orange arrow button to hide the control panel at your own will. You can change the settings on this view at the top of the panel on the right hand side. You are encouraged to please forward any questions that come up during the questions using the questions tab. Your questions will be read after the featured presentation, and we will identify who is asking the question in order to foster participation and interaction between the attendees. However, if you would like to remain anonymous, just let me know. We'll also have a live poll session at the end. If you are able to answer from your screen, there are some multi-choices there, and we will share the results at the end. And finally, at the end of the meeting, we will have a follow-up survey. If you can, please respond to the questions so that we can incorporate your feedback into the work of the community. Thank you. We now start the presentation. I'm Stuart Young, and I represent FIATech in Europe and the Middle East, and also Comet in the UK. On behalf of all of us at FIATech and Comet, I'd like to thank you for joining us today for the Mobile IT Community of Interest November monthly meeting. Today's presenter is Brian Sweeney from Trimble, who will present on Trimble's Connected Site, a fantastic technology that helps customers manage and share information in real time through connected machines and web service products. Before we get started on the Trimble presentation, I'd like to take a minute to introduce this community of interest to those who are not familiar or members of either FIATech or Comet, and who are new participants to the community. The objectives of the community of interest is to truly showcase the mobility solutions that will or have been adopted in the capital projects industry. We strive to achieve this goal by presenting the latest cases of mobile IT adoption, and also by allowing the breadth of the community participants to expose their perspective on these technology applications. We've been delivering use cases and industry perspectives through various channels, including these monthly meetings, and virtual and live discussions, documentation reports from the gatherings, and also by facilitating the creation of research and development projects within both organisations. The community is another joint venture between FIATech and Comet. A bit about FIATech. It's a member-based organisation with an objective of improving the productivity of capital projects through the deployment of technology. Our goal is to improve productivity in the capital project sector through the adequate leadership in global development and adoption of innovative practices. Comet, which stands for Construction Opportunities for Mobile IT, is a UK-based organisation whose principal aim is to learn from experience to deliver measurable business benefits in terms of adoption of mobile technologies. This partnership supports the work and objectives of the community. Who's in the community? Well, we've got approximately 1,450 participants from over 420 organisations located in 42 countries around the globe. Mainly participants are located in North America and Europe, but as we continue to expand into the Middle and Far East, we're beginning to attract participation from South America and elsewhere. We're made up of owners, operators, EPCs, software vendors, academia and subject matter experts. We're very glad with the industry's response so far, and we are continuously working to meet the needs of our participants. Some announcements. Next April 3rd to the 6th, we've got a mobile IT session at the FIATech Spring Conference. Just have a look at the website for more information. And we've also got on the December 3rd in the UK, we've got a Comet Community Day, which is being hosted by IFS just outside of London. Again, further information, please see the website. So I'll move on to the main presentation, in which Brian will explain to us how Trimble's connected site works. A bit about Brian. Brian is a product manager with Trimble Navigation and has been developing software solutions around helping the civil construction industry become more productive. Brian has a strong background with both horizontal civil projects and vertical building projects. Before Trimble, Brian ran a small startup that helped projects manage job site progress photographs, and before that he spent 10 years working as a project manager and field superintendent on large commercial projects. Brian is located in Westminster, Colorado, and works in the civil engineering and construction division for Trimble. Brian, I'll pass it to you now.
Thanks, Stuart. Okay. Can everybody hear me? Is my screen showing up?
Loud and clear, Brian.
Great. Well, thanks for having me. I'm going to talk about our connected site, and really this is a initiative that we have that brings technology to the job sites for the heavy civil construction industry. We focus on three main software pillars. Our Business Center product, which is where we do 3D design and data prep. So this is where users can go ahead and take a set of plans, digital or even 2D, and basically put a constructible model together and then send that out to the field. We've got the Connected Community, which is our cloud storage software. This is where you can share design files from your desktop out to mobile devices, and then also manage machine files that are coming off the machine, providing real-time as-built data. And then we also have a product called VisionLink, and this is our fleet management product where you're seeing not only utilization information coming off the machines, but also as-built data that's streaming off the machine as well. So when we talk about Business Center, this is where design files are prepped, and this is where we're building the constructible model that can be sent to the machine. You know, even if you do receive a 3D model, oftentimes there's issues with the layers, or things need to be adjusted and tweaked and filtered out. So through Business Center, we provide a number of tools that allow people to put together surfaces, get their constructible model put together, and then this ends up being ready to be sent to the machine. So there's tools inside Business Center that can send designs to the field. So you can run it through our Connected Community or cloud environment. So this provides over-the-air file transfer to data collectors and then control boxes that are located on the machine. Or if you want to, you can also run it manually just by putting the file on a USB and uploading it to the machine. So we offer a couple different options there. Once the design file hits the machine, this is kind of what users can expect. You're basically chasing target surfaces with the machine control systems. And for people that aren't aware of how a machine control system works, we'll get into that in a little bit. But basically, we're sending a target surface to the machine, and the machine is then chasing that target surface using automated controls on the machine. Now, during the construction process, if there are issues out in the field and somebody is having trouble maybe understanding which design they might need to be in or how the controls work or something like that, we also offer a product called Remote Assistance. And this is a way for somebody in the office to remotely connect to either one of our rover devices or a in-cab display. And what can happen then is you can actually take over control of the display box and make adjustments or walk somebody through the issue, or even provide kind of on-the-job training remotely. So it's a nice feature that we offer to help people out in the field stay connected and get their questions answered. When it comes to the machine control systems, they rely heavily on correction service. So we offer a base stations, but we also have what we call an internet base station service, an IBSS service. And what this allows us to do is stream GNSS corrections over the internet, and we can actually reach up to about 20 miles with very high accuracy corrections. What's happening is we're just streaming the correction from the base station to the machine. So the machine is connected out in the field. It's getting the corrections over the internet, which is kind of interesting. And a lot of customers, there's a little screenshot here over on the right side of the screen showing that this is a location in Westminster where our office is, and this is just showing the reach that we get. So somebody serving a large metropolitan area could set up a base station and use that as their correction service in their area, and it's becoming more and more popular. When we talk about the grade control system, this is a very popular product of ours where systems are hooked up into the machine, and we're controlling the hydraulics of the machine to chase that target surface that we were just looking at. So there's a number of different options for this and configurations and setups that people can use, but this is just a good example of the hardware that gets put out on a machine. And when we talk about mapping and chasing these targets, what we're really looking at is like a one-by-one grid that as the machine is passing over these cells, we're actually mapping what's going on, and you can see that if a machine passes over these cells, the following cells that are green would get mapped with a whole bunch of rich data like elevation. It would know which machine passed over it, the date and time. We provide a bunch of sensor information that can stream off. So for example, if you're compacting asphalt, you can put a temperature sensor on the machine, and it's going to provide us with temperature data for each 1 foot by 1 foot cell. And then there's compaction sensors that measure the compaction meter value, the CMV value, that can also be reported. So you're getting a ton of rich data on a 1 foot by 1 foot grid, and this information can then be streamed off the machine and into our other services. So the way that works is we have these telematics boxes, and to stream 3D data off, you need one of our higher end boxes. This is an S&M 940, and what this is doing is it's not only providing rich telematics data information about when the asset gets turned on, when it starts and stops moving, that type of stuff, but it's also streaming all that rich 3D data off the machine. And the way that works is you can either run it over cellular or Wi-Fi, and then that'll stream up to this connected community, that cloud storage space that we were talking about. And then from there, applications like VisionLink can pull it down. This is also how you get designs out to the field remotely. So from business centers also talking to this connected community cloud space and streaming designs into that and then down onto the machine. So this is really a key part of connecting our machines out in the field. And this slide talks about some of the things that can be done with this 3D project monitoring information. So inside VisionLink, we really focus on two main things that we do with this 3D information, and one is we do a bunch of as-built mapping, so we can tell you exactly where the machine was, what it was cutting, what elevation it was at. A lot of this is for volume summary and tracking progress, tracking maybe airspace for a landfill or something like that. And we see this primarily used with motor graders, dozers, excavators, where they've got mapping on these assets, and they're providing real-time as-built updates each day. Somebody can go into the system and get a progress update on where their machines are at and how far they have to go to get to their target design. So that's really the use on the as-built side. But we also found and developed some really nice intelligent compaction tools as well. So if you're not familiar with intelligent compaction, we'll get into that in a little bit. But what we're really doing is tracking exactly where the compactor was. We're tracking pass counts and then the CMV value that I mentioned earlier. So it really provides us with a ton of information about where a compactor has been, how many passes it's been, and then we're really painting the control box screen green. So they'll set and say, hey, I want a pass count target of 3 or 4, and then basically we'll end up mapping the entire project to 3 or 4, and they're just looking at turning the screen green. This is an example of some as-built data that's coming off the machine. So this is associated with that similar screenshot we showed at the beginning in Business Center. So this is as-built data inside Business Center. We're getting this information streamed in, as well as streamed into VisionLink. So the way I look at the difference between Business Center and VisionLink is, Business Center is where a lot of data prep and modeling and kind of advanced drafting and CAD modeling tools are done. And then on the VisionLink side, this is where somebody could go in and get a quick update. That's a site supervisor or a project manager. They can go in and see their data and quickly get to what they need. We offer a lot of simple filtering tools that make it easy to use. Here's a section slicer. So this project, they're working on a big spillway, and I'm showing a couple different filters. So here I'm showing the highest pass. So this is basically where the project started, and then the last pass, so I can see exactly where I'm at today. And you can monitor your volumes, and the yellow line that you see on the bottom, that's our target surface. So that's coming in from Business Center, and it's published into VisionLink as well. And then I'm tracking my target surface against that as-built surface, that purple surface that's the last. So there's a bunch of different things that you can do here. You can monitor, how much volume you have left to move, how much you've moved, and then there's a number of additional filters that you can apply in a bunch of different heat maps, such as like cut fill and that type of stuff, so you can quickly see where you're at and where you need to go. We've noticed a lot of people are using this technology for underwater dredging activities, and oftentimes they'll send people out on a boat and have to survey the surface, and they're dropping a rod down, or we've heard of a bunch of different ways that people survey the surface. With this as-built mapping, they can actually get that information right off the machine and then run like a lowest pass filter. So it'll take the lowest elevation and provide them with a nice surface showing the lowest pass of their equipment as they were digging underwater. So these are just a couple screenshots of projects that we've worked on that we're using that technology, and it's provided a ton of cost savings for these organizations that were having to go out and survey and prove to the owner that they had dredged down to the correct depth. This screen here is showing how the as-built data that you're seeing in VisionLink can also be brought into Business Center. So we've got a 3D design model here. This actually happens to be for a landfill. We've got a number of landfills that use this technology. They put the compaction system or grade control system on their compactors, and then they're mapping pass counts and then also as-built data, so where they're at. So this is just an elevation filter showing where they're at, and so they're providing real-time survey updates, every day. And this combined with some of our aerial as-builting really helps these groups stay on top of where they're at and where they're headed. So this is a shot of a landfill design that was surveyed using our fixed wing UX5 survey drone product. So what ended up happening was we surveyed the project and brought in their design, and then we're also providing them with daily as-builts of where they're at and helping them calculate the density of their landfill. So we've integrated that with our Vision Lake product, and it's proven to be very helpful for this segment of the industry. Jumping back to the intelligent compaction, this is a shot just showing how the mapping works. So we're really just tracking where the asset has been with super high accuracy corrections. And you can see that this picture on the bottom is a chart showing what a typical project might look like without intelligent compaction mapping on the asset. So you're seeing a lot of like one and two pass cells on the edges, and then you're seeing a lot of green down the center. So what ends up happening is you get a very inconsistent road base, and this obviously will lead to problems down the road. So owners have really liked adopting this, as well as DOTs, so they can guarantee that the contractor is passing over the cells the correct number of times. It's very hard to be out there and monitor this stuff without some technology. And the system ends up providing a lot of cost savings to the owners as well of the equipment, knowing that they only have to pass over the cell 3 times, and once they pass over the cell 3 times, they've got proof, and they can stop their roller and save some fuel. And it also provides that documentation that they often need for at least local state projects here in the States. It seems to be something that's picking up and catching on. With the intelligent compaction system, what we really end up doing is correlating a past traditional test with data off the machine. So we know how many times we ran over that cell that passed, and we know what the compaction meter value is, the CMV value. So we can set those values in the box and say, all right, I know that if I run over the cell 4 times and I've got a CMV value of 85, there's a good chance that I'm going to pass the next test that pops up. So you can then correlate all of the cells with that known passing value, and you end up being able to map and deliver a much more uniform product that is most likely going to pass the test. And then if you do end up, it hasn't replaced the nuclear density testing, but it's definitely helped contractors and owners feel more confident about passing areas that have been mapped, or maybe testing less, knowing that they've got uniform coverage. So here's a screenshot of what the compaction meter value mapping looks like. So you can see up on the top edges, we've got lower values, which might correlate to lower pass counts, and where we are at in the center, we've got more green. So this was just a little snapshot of a project, but it provides both the contractor and the owner with great information that they can go back and say, hey, I'm concerned about these edge cases that are blue, that are under compacted. Let me go do some testing to find out what's going on there. And then obviously the the areas in red are over compacted, or they're not, they're at a state where you can stop compacting, and this will help save time and fuel, saying, you know what, we're good here. We don't need to continue. Additional work is just going to, it's not changing the compaction value of the material. It's just additional work that we don't need to do. So switching gears a little bit, we also have some technology around earthworks monitoring, and this is keeping track of load and dump cycles. So we can hook up these telematics boxes on dump trucks as well as scrapers and track load counts for both of these assets. These are the typical ones that we doing. And basically what we're able to do is replace the log or the clicker that is in the cab. So this is real project data. I mean, we were working with a customer and they were entering all of this by hand manually. Somebody would take this all back into the office on a semi-regular basis, enter these load counts into an Excel spreadsheet, and then run reports, volume reports, so they could calculate how much material they moved each month. And then they were also then correlating this with the clicker count and that type of stuff coming from the cab. So it was a lot of manual work, a lot of time spending just collecting and managing the data. And what we were able to do, let me switch gears here. We were able to provide a report that looked like this, that gave them exact time and location information on where they picked up and dumped. And this is an example of the same report that we monitored versus theirs. They had 30, we had 30 loads for that date in September. And we provide a bunch of rich data that then can feed back into our system, and we can use it for other things that I'll show you here in a second. This screenshot here is just explaining a little bit about the technology on how this works. Basically, we've got a telematics box that's on the loading asset, on the excavator, and one on the hauling asset, the dump truck. And what happens is when that dump truck enters a cut or site boundary, we're aware of the entry event, and when it stops within a proximity of the loading asset, we know that that asset is contributing to the load. So we're actually tracking who loaded the material and then which truck it was loaded into. And then each of these trucks have an estimated volume. When they leave the proximity and leave that radius of the excavator, we count that as a load event. And then when it comes to the dump event, oftentimes, and we strongly recommend that people hook up these telematics boxes to a switch that either is a bed up switch that's in the cab, or they can do an external switch on the back of the dump truck just to keep track of the switch event, so you can go and dump that material anywhere. But what happens is you'll enter a fill site or another area on the project, and when you have that dump event, that's going to count as a dump. So we put the load and dump events together to determine the cycle, and then all that rich data gets reported back into Vision Lake, so people can monitor their load and dump events. And this ends up all getting fed back into a mass haul plan. So in Business Center, after you design your roadway, you're able to basically take that mass haul plan and create a basically you're able to publish that and then monitor the load and dump events that are occurring inside Vision Lake. So what happens is, in Business Center, you'll put this plan together, and then it'll get published to Vision Lake. And one of the nice things that happens when you're monitoring this inside Vision Lake will create these cut and fill zones automatically. And what what then gets reported by the truck gets backed out against the targets that you're chasing based on your cut fill plan. So you can see I've got a number of different zones here. Some of them are more complete than others, just based on how the project's going. So I can see that zone 1, I'm about 76% complete, and then you know, there's a zone 20 and some of these others are also being worked on. And then there's an overall progress bar showing how, based on my targets that I put in the system, how close I am to being complete there. So basically all of your load and dump events are being tracked against these target values, whether it was, you know, a cut situation where you were loading from one site and then dumping in another. The ordinate chart comes across, so you're seeing cumulative cut and cumulative fill in these areas as well over your station range. So this is all a bunch of detailed information that comes across from the mass haul plan in Business Center, and it's available inside VisionLink, which is our, you know, web service product. We're able to then track how each asset was performing for each zone, so we can see which assets are contributing to which zone. In this example, those green bars all represent a different truck and the volume that they contributed to that zone. And then you can see over time how your material was moving. So, you know, for whatever reason, they had some up and down, you know, events, whether that was due to potentially days off or whether people can then get, you know, detailed information about how they're moving the material and track things that way. And then this is one of the things that we have heard a lot of great feedback from, this burn down chart. We're able to show the customer their target volume that they want to move, and then track that against the amount of material that they are moving. So the red line is their target. If they're going to move this amount of material by this time, this is the rate that they need to move the material at. And then the blue line is showing their actual rate. So you're able to identify areas that are maybe problem spots earlier. Based on this, you could find out that, hey, I'm not moving as much material as I need. You could troubleshoot and figure out if you needed additional equipment, or hey, am I going to finish on time because I'm actually moving this material faster than I expected. So this provides just a great snapshot tool of where you're at on the project. You can see at this point in time, it looks like that they're going to finish a little bit late if they continue at this pace. So some corrections may need to be done for them to reduce their their end date and have an on-time finish. Now, getting back to VisionLink and these telematics devices that are on our assets, they're not just streaming 3D data in; they're also tracking, where an asset is, what the status is, whether the asset's on or off, or if there's issues with it, maybe not reporting if it hasn't reported in the last month. So the VisionLink product, up on the top, you can see that there's a number of different tabs. So you've got fleet, alerts, health, maintenance, utilization, project tab up there. So when we talk about the fleet, this is kind of showing just dot on the map where it's at. Is it turned on? When did it last report? That type of stuff. And each device reports differently. So some might be satellite devices that only report once or twice a day, and others might be, very high-end devices that are reporting every minute type of thing. So you get a bunch of rich data depending on the asset, and this is where you would see that. You can also get alerts on. So I could set up geofence boundaries and say I want to know when a asset has left my project, or I want to know if an asset gets turned on Saturday or Sunday, or maybe I want to have an alert when an asset gets turned off, something like that. So there's a bunch of different alerts, and these all can be like set up as email or text messages, and so there you can manage those through the alerts tab. On the health side, we work with Caterpillar a lot on this. There's a ton of great health information that gets streamed off these assets, and it'll show fault codes and that type of stuff. Then you can also manage your maintenance. So OEMs can put in their maintenance schedule and recommended maintenance. And if you work with Caterpillar assets, you can also like order parts through here as well. This is used by the dealers quite a bit to manage fleets for customers. And then the utilization tab, this is one that we'll take a look at. This shows a bunch of information on when an asset was turned on, whether it was working or whether it was idle. And then the projects tab, that's where we're looking at that 3D project monitoring that we had just taken a look at. So on the utilization side, this is where you could see a month view. So this is, I'm looking at the month of March, and I can see how my assets are working, which ones are being turned on and used. And this is a good way for somebody to look at, there's a dump truck down here that seems to only get turned on maybe once a week. Somebody could take this and help balance their fleet out, or somebody might need some additional assets. You could see which assets are actually being used, and you can drill down even deeper and see, okay, an asset may have been turned on, but how much is it actually getting used? And you can see that there's a couple assets here that are showing quite a bit of idle, and then there's others that are showing quite a bit of, so the idle is the idle is the orange color, and then the working state is green. And then where you see the blue, this is a situation where the asset's not reporting enough information for us to tell if it's working or not, or the customer hasn't bought the utilization subscription, so for that asset. Oftentimes with an excavator, they're stationary, even though they're working all day, they're just in one spot. And unless we have the ability to put some switches on the excavator to track if it's working or not, but oftentimes people don't track whether those are working or idle, because they'll show a lot of idle, and it's kind of deceptive because they actually have been working. And then this can all get rolled up by asset and by day, so you can filter and slice and dice this information. And then what we're seeing here is just how the assets were being utilized each day, and then you can also compare assets to see which assets are performing maybe better than others, and this will give you an idea of where you're at each day. So I know I've covered quite a bit of stuff here relatively quickly. I recommend, if you want to learn more about some of these technologies that we've just covered, to check out our website. That just go to construction.trimble.com, and that's going to take you into the civil engineering and construction area of our website. And there's a ton of great stories, and we actually publish it's quarterly a magazine that talks about a number of different business cases and case studies, and how we've helped customers across the world with a number of these different products. There's a lot of different combinations and a lot of different things you can do with these products. So that takes me to the end of my slides. Sir, do we want to open this up to some questions, or?
Yeah, we'll just let me just take it back 1 second. I've got some poll questions now, which I'm just about to launch. Just give me a second. I'm just bringing my screen into view. Okay. Yeah, we have some poll questions. Thanks, Brian. That was quite enlightening. Some tremendous attributes there of the system, and I'm sure, looking at the number of questions we've got, I'm sure there's people looking for more information. Just bear with me a second. I'm going to launch the polls now. So the first one I've got coming up here. Have you been involved with a project using machine control technology? We've got multi-choice answers here. Let me just launch this. Give you 30 seconds to pick out with that. That's interesting so far. Another couple of seconds. Okay. I'll close that and I'll share that. What are your thoughts on that, Brian?
I'm not surprised. I think that sometimes we think that more people are actually exposed to it, so it really shows that there's a lot of opportunity for us to reach out and work with customers that might be interested in learning more about this technology, because it really does, from the machine grade control side, that's where we see a lot of cost savings and the ability to go and help customers with this.
Yeah, absolutely. Okay, well, I'll move on to poll question 2. And that is, have you explored mapping progress with aerial photogrammetry survey? That's interesting too. So a third have done that, approximately a third.
Wow.
Couple of seconds.
No, I mean, there's lots of activity in this area, and it's definitely an area that we're focused on. So that's good to hear.
Yeah, absolutely. Let me share that. So 22% yes, 74 no, and 4% other. Okay. And the final question I've got here is, do you have telematics software on your machines? Brian, any thoughts on that one?
I think more and more people are using this type of technology just to track where people are, so I would expect it to be maybe similar.
Yeah.
Okay.
Okay, thanks everybody for voting on that. I'll move on with the rest of the presentation. So we got some questions in addition to those polls that have come in, and I'll just get those up on the screen. The first question's from Cody Lowry. Is there a way to track when the system is in auto? Brian?
So I'm assuming that this is around the grade control system.
I think it probably came in about that time, yeah.
Yeah, so there's some ways that in the control box that you can map when the system's in auto, or you can always turn it so it's always mapping. So in the control box that there is the ability to control whether it's in auto or not, and whether it's mapping in auto or not. And then on the flip side, in the Vision Link side, that there's some additional areas that you can filter based on Sometimes there's a sensor that you can put on for a dozer where we're actually, or a motor grader where we're sensing the blade on ground activity. So we can put it so it only maps when the blade's on ground, and then when you pick the blade up, it doesn't map. We do have some technology around that, and then you can also filter whether you're going forward or backwards. So in a dozer situation, you may only want to map and see the data when the dozer is going forward, and then have it turn off when it's going backwards, so that there's a number of different filtering options that we can set up depending on the customer's need. But yeah, that's definitely been something that we've focused on.
Okay, thank you for that. The next question I've got here is, what is the accuracy of the readings with sensors? And that's from Mohammed Osman.
I don't have the exact accuracy on like the temperature sensors and the CMV sensors, but I know that they're highly accurate, and we end up having to provide this data to DOTs. So some of it depends on the exact location on where it's at on the machine, but it's going to give you very accurate information on the sensors. But if they want to reach out to me, I can probably get some specs on those. I just don't take care of the hardware, so I don't have a ton of information on the exact accuracy. But I know that it's something that DOTs and other agencies, federal agencies, will accept and take.
Okay.
So for that,
Thanks for that, Brian. Next question I've got here is from Peter Lesensky. Can data be accessed by third-party software?
Yes. So on the VisionLink side, we offer a number of API or application programming interface feeds that people can access and actually feed out this data that they own. So you can feed out location and time and load and dump information that could be fed into another system. As far as what's available, there's probably 20 or 30 different API feeds. So we do allow users to feed out that data through VisionLink that could, and then you could write a program or have somebody put together some custom information or a custom program that does what they want to do. And we have a number of customers that do that. It's pretty surprising. They'll feed this information into their ERP systems and stuff like that. So
sure.
We do offer that.
Okay, another couple of questions here. Another one from Peter. Where do we get the info on the APIs?
So it's available through once you have a project. There's a link inside VisionLink that lets you get information on the APIs. It's publicly available, so I can share it with him if he wants to reach out to me. I think my email and that kind of stuff is on the front slide. Or
sure, yeah. Well, we can share that.
Yeah, I can get that directly to him. It's not so. If you go to myvisionlink.com or inside the Trimble websites, it doesn't jump out at you. It's something more for customers, but I can get them that information.
Okay, Peter, if that's acceptable. Otherwise, just contact me and I'll put you in touch with Brian. Next question we've got here comes in from Mark Hess. The question is: we work with several contractors across a variety of sites. Can this technology be implemented and utilized by them under, say, a subscription to the business center, or is this only for Trimble use?
As far as Business Center goes, that's it's a desktop solution, so it's not a subscription-based. And maybe I'm not sure I understand the question. Could you rephrase that? Do you know what he's kind of getting at?
I think is it a case of, do they lease it? Do they buy it? How do they go about appointing it for the projects? I think that's my interpretation of what Mark is asking.
Okay, so I know from a hardware side, some dealers will lease grade control systems, that's kind of up to the dealer on if they want to do that, and then you can buy systems individually. I know that on a lot of federal DOT projects, we're seeing dealers leasing grade control systems for those projects. As far as the software and the hardware goes, VisionLink is a subscription-based service, so people pay monthly subscriptions based on their asset. And then on the Business Center side, that's a desktop solution that you purchase modules, so there's a number of different modules depending on what you need. We do everything from like tunneling to drilling and piling to roadway stuff, or site-based projects to mass haul. You buy the modules that you're interested in, and then those are one-time fee, and then you've got maintenance fees if you want to have support and that kind of stuff as well. So we offer that.
Okay, I've got another couple of questions. Oh, Mark Hess says thank you very much, by the way. I've got another question here. It's around material savings. Obviously, to work to the sort of fine end of the tolerances, what typical savings have you seen using the system?
So the big thing that we see on the material saving side is that being able to correctly lay down the correct thickness of expensive like subgrade base materials is essential. Basically as you get closer to that top surface, your materials get exponentially more expensive. And so if you can have your subgrade base laid down at the correct thicknesses, you end up seeing cost savings there. And from what I've heard and what we've published, customers can expect 15 to 20% on savings on their material. And it definitely varies, but being able to lay this down at the uniform thicknesses is critical when it comes to those top layers.
Okay. Obviously, the higher up you go, the more expensive the material is. Yeah. Okay.
Yeah.
The next question I've got here relates to safety. Obviously, with less boots on the ground, less movements, what sort of typical safety improvements have been reported using the system, Brian?
One of the projects that we're working on now, they're doing a lot of dynamic compaction and dropping weights with a crane, and then we're helping the customer map this. And what's happening is that these things are basically eliminating 3 people that needed to be on the ground to survey and lay out where these events occur. So there's a bunch of different stories around this and how it can help reduce, like what you're saying, boots on the ground. We definitely help eliminate stakes and the need to be out there surveying and putting stakes in the ground at every station type of thing. So that type of reduction in boots on the ground is a big safety saver.
Yeah, absolutely. The other thing, of course, is the significant reduction in both wear and tear and use of fuel. What do you get reported on that?
I'll be honest. A lot of that has been managed on the Caterpillar side, as far as what they've actually seen as reduction in wear and tear on their assets. I know that when we're talking about compactors and whether they're working on level surfaces and that kind of stuff, that's been something that the group has been focused on, is making sure that they're that assets are not being overworked and that type of stuff. I don't have great numbers on that just because it's not an area that I focus on, but I know that we can find some information if somebody's interested in reduction in wear and tear. You know, we see a lot of great cost savings on reduction in fuel, where an asset doesn't necessarily need to be running when it is, or you know, through some operator training, an owner can say, hey, instead of us, you know, idling during our lunch, let's shut our assets off, or you know, we only need 5 minutes or 10 minutes of warm-up time in the morning, that type of thing instead of 20. They're able to identify those areas of long idle time, and customers have said that they've seen you know, 15-20% cost savings in fuel on that side. And then being able to do preventative maintenance is key, knowing when fault codes come off a machine, and is that fault code a critical item, or is it less critical, is very important for just maintenance. You know, a small gasket could be changed that could prevent you know, replacement of an engine.
Sure, sure. Well, that sort of concludes the questions. I've got a thank you that came from old Scott Rubin. He's saying fascinating look at the future of the industry. Thanks for your comments on that. So that sort of,
that's great.
Yeah, that sort of concludes the questions and answers. So I'll just nip on to the next few slides and close out. So join in the conversation. Some Trimble contacts there. As I said at the beginning, this presentation will be made available in a day or two on YouTube. Continue the conversation with Fiatech and Comet. Lots of social media connections there. And we will issue a follow-up survey as well. Please take the time to have a look at that. We do treat it with significant value. We've been able to shape the community since we started, listening to what people have said and what they'd like to see. So yeah, please go ahead. The other thing I will say is we've got the spring conference coming up in Austin in April 3rd to the 6th, and one of the proposals we've got to have in presentation is the intelligent and automated construction job site, and aspects such as this would fit as a key component within. So please watch this space, because that's very likely to occur, and we would bring in Brian and others to talk about what advancements we've got at site level. So yeah, continue the conversation. Follow-up survey. I'd like to say thanks very much to Brian, and thanks to Vineet. Vineet's been sat in the background. Vineet's provided some great input to make this happen, and we look forward to seeing you on the next session. Brian, have you got anything else to say to close out?
No, I'd just like to thank you for the opportunity, and we're very interested in putting technology on these job sites. So if anybody has any questions or needs some additional information on this, you know, please reach out to me, and I can help get you in touch with the right people.
Brilliant. Well, thanks very much, and have a good day. Cheers.
Yeah, thank you.